So what we have seen last time is the selection of flat belts, and we are going to see step by step how the flat belts are selected. Out of that, if we are going to see, then right from the first point, the procedure which we have seen step by step, and that first procedure we have seen that how to select the standard dimensions of the pulley. Later on, we have seen that second point, that is finding the speed of driver and driven pulley using thickness of that belt or without thickness of that belt. In both cases, we have seen how to find the speed ratio. Then we have seen determination of correction factor. Okay, so this is step number 3, in which we are going to see the correction factor for the power. That is power which we are going to use for the design or the selection of that belt. Then this is step number 3. In that, we have seen how that power is corrected, and that is depend upon first of all that load correction factor, because formally which we have seen for the power correction factor or finding the design power, that rated kilowatt, that is nothing but the power which has been given in the problem statement, for which we have to select the belt, that we have to take. Later on, the load correction factor, then arc of contact factor, and smaller pulley diameter factor. Out of that, this point A, which has divided, that is load correction factor. For that, this is the table which we are going to use for the load correction factor. And later on, we are going to select the arc correction factor. In that, just we are going to use one formula by means of which we can go for this arc correction factor. And for that, the angle, that is arc of contact and arc of contact factor, that table has to be used. No doubt that already I have told you that these type of tables will be provided to you at the time of your examination while you are solving such type of problems. Either they will be printed, these tables will be printed in your question paper, or separately charts will be provided to you. Okay, so these tables, and from that you can select the angles as well as you can select the factors. Okay, then next thing is that smaller pulley diameter factor. Now this smaller pulley diameter factor, that is depend upon what is the dimension of that smaller pulley, because in that case this smaller pulley dimension factor is considered or taken, because in case of smaller pulley the angle of lap is less, or either it get vary because of the what its change. Okay, because of its dimensions. That's why we are going to have this factor. Okay, and that is nothing but that is again selected from the range of the available dimensions of that smaller pulley. That is diameters up to 100 millimeter. We are going to have the 0.5 as a smaller pulley correction factor or diameter factor. 100 to 200, 0.6, 200 to 300, it is 0.7, 300 to 400, it is 0.8, and 400 to 750, it is 0.9, and above, if suppose we are going to have the smaller pulley dimension above the 750 millimeter, then we are going to use this power factor, smaller pulley diameter factor, as a 1, and above that we will have consider only that value 1. Okay, so that is again depend as already we have discussed, because this angle of lap in case of smaller pulley is less than 180 degree. If you are remembering this diagram and the discussion which we have done, okay, are you able to see it? Hello, will you please respond me? Anybody of you?
Yes, sir.
Okay. So is it visible?
Yes, sir.
Okay, no problem. Then this smaller pulley diameter factor is considered because this angle of lap for the smaller pulley is less than 180 degree. That's why we are going to consider this angle of lap factor. Okay. Basically, it is we are going to say it as a smaller pulley diameter factor. And if the diameter is sufficient large, then it is not necessary to consider any factor for that pulley, right? So, is there any question up till now for all the steps which we have seen? Any doubt? You are free to ask. Hello? Do you have any doubt related to the steps now? We have seen up to step number 3. Do you have any doubt? You are free to ask. Hello? Can anybody of you tell me what uh, doubts you are having or any problem? Hello? If not, you can say no, no, sir, we don't have any problem. Hello?
No, sir.
Okay. So we'll go to the next step. That is step number 4, and that is finding the belt velocity in meter per second. Now, as we are knowing the angular velocity of pulley, then one can easily calculate the linear velocity of belt. Now, this v is the linear velocity. As we know that v is equal to r into omega, right? And this omega is calculated by means of what? 2 pi n upon 60. Am I right? So here, if you are going to derive this equation, let me derive it. You can have just a minute. So if you are remembering what is v, v is equal to r into omega. Am I right? Hello. If suppose we are going to calculate,
Yes, sir.
yes, right. So if suppose you are going to calculate velocity of any point which is on the circle, if this is a circle on which you want to calculate velocity of any point will consider it as a this point here, and suppose this black point is there, which is point on the pulley which is rotating with the angular velocity omega. If it is rotating with the angular velocity omega, suppose this pulley is rotating with the angular velocity omega. So how you are going to calculate the angular velocity of pulley? By means of considering 2 pi n, right? So this omega is calculated because here in this case, this omega is given by, yes, omega is equal to 2 into pi into n, where n will consider as a n1 is the speed of smaller pulley. Okay, so I'll write here as a n1 2 pi n divided by 60, right? So this n1 speed which you are going to consider is the speed of smaller pulley. One can consider the speed of bigger pulley also. But while you are going to select this speed of bigger pulley, what you have to do, that you have to consider this r depending upon whatever may be that radius of bigger pulley. Am I right? So when you are going to select this omega is equal to 2 pi n1, n1 is related to the small r. And if you are going to select n2, it will be related to the capital R, where the capital R is the radius of bigger pulley and small r is the radius of smaller pulley. Here you can write it as a r is equal to, that is small r is equal to d, that is small d, divided by 2. So when you are going to put these values in the equation, v is equal to r omega, that 2 will get cancelled and remaining value will be 2d, that is pi d into n1 divided by 60, and that will be in meter per second, provided that this diameter should be in meter. Am I right? So by means of this formulae, you can easily calculate what will the speed of that belt, that is linear speed of that belt, by using either diameters of the bigger pulley or diameter of the smaller pulleys. Get it? Any question? Hello? So here, what we are going to see is the D is the diameter of smaller pulley and N1 is the speed of that pulley, that is the smaller pulley. Okay. And we are going to consider it as a driving pulley. So we have completed this. Any question related to the step number 4? If not, we'll go to the next, that is step number 5. Now selection of belt. These belts are selected from the manufacturer's catalog, and you know that Dunlop is one of the manufacturer, and basically this Dunlop company has given this type of design procedure where we can select these belts from their catalogs. So there are basically two types of belt which we can select from the catalog of Dunlop. Okay, and out of that, first is high speed 878. That is the name of that belt. Okay, and that is called as duck belting. Okay, it is just name. We cannot say anything to this name. Okay, these belts are used for the light and medium duty applications. Okay, with high belt velocity. A belt velocity is very high. In that case, we can go for this 878G duck belting. Okay, and if we want to have for the heavy duty application with medium belt speed, then there is second category, and that is called a Dunlop front 949G duck belting. Now these two belts or two types of belts, just they are differ by means of this name. This is all thing is name, that is Dunlop high speed 878G duck belting. Okay, This is the name which has been provided and number which has been provided to that belt. Whereas this is the second type, that is Dunlop front 949G duck belting, and which is the name of that belt. Now this high speed belt is used for the medium and light duty with high speed of that belt, whereas the second type is used for the heavy duty application with medium belt speed. Okay, so where we can say as a high speed and medium speed and high, that is heavy duty and light duty. So for designing power which is less than 20 kilonewton and belt velocity is greater than 16 meter per second, it is called as high speed and light duty application. That is, power rating is below 20 kilonewton, and whereas speed of that belt is more than 16 meter per second. Are you listening me? Hello?
Yes, sir.
Yes,
Yes.
and hope you are understanding it. Okay, so this 20 kilonewton and 16 meter per second, these two figures we have to be keep in our mind. For that, we have to go for high speed 878. Whereas if the power rating is above 20 kilonewton and if belt speed is below 16 meter per second, then we are going for the second type, that is 949G. Okay, so these two categories we have to be understood, and where they are used, that we have to understand. So heavy duty and light duty, as well as high speed and low speed. These are the two criteria which are used for the selection of these two types of belt, that is 878 and 949. Now next step is determining number of plies. Once you are going to either select high speed, or you can select this 949 belt. Okay, out of these two you are going to select any one belt, and that is depend upon power rating. So design power which we have calculated previously, that design power, if it is coming below 20 kilonewton, and the velocity which we have calculated previously, that is V, belt velocity, which is greater than 16 meter per second, then we are going to select first type of belt. If the power rating which we have calculated, that is design power by means of formulae, that is the step number 3. By means of that, when we are going to calculate the power, then if it is above 20 kilonewton, and by means of step number 4, if you are going to get the velocity as a above 16, sorry, below 16 meter per second, then we are going to select this second type. That is the only thing which we are going to do at the step number 5. Okay. Once out of these two, you are going to select either high speed 878G or front 949G. Out of that, if you are going to select, then next step is the step number 6. Hope you don't have any doubt for this step number 5. If you are having any doubt, you are free to ask. Hello? Hello? Do you have any doubt?
No, sir.
No. Okay. Then we will go to the step number 6. Now the step number 6 is related to the determination of number of plies. Now one has asked me question that what are the plies? Plies are nothing but the number of layers which you are going to have for the belt, because belt is manufactured in the layers. These clad belts are manufactured in the layers, and each layer is having capability to sustain some amount of power transmission, as well as its extension and all other properties which are related to the belt. So number of ply, increasing number of ply, it means that you are going to increase the capability of that belt to transmit more power. Okay. So in that case, when you are going to select the number of plies, such type of table will be provided by means of manufacturer, as well as this type of table will be provided to you at the time of examination. And what you are going to see in this table, you are going to select first of all maximum belt velocity, which you have calculated in step number 4. Okay, and depending upon that maximum belt velocity, you are going to select what will be the number of plies. Okay, and the second thing which you have to take care, that is the diameter of pulley. Okay, and that will be the minimum diameter. Okay, minimum diameter means smaller pulley diameter. If you are going to have these two data, that is the speed of that belt in meter per second, this what first thing which has been written here in bold, that is the speed, and are you able to hear me? Hello, can you hear me?
Yes. Yes, sir.
Okay, okay. So what we are going to see is that in first row, that bold figures that are for the velocities of belt in meter per second, whereas the all other this table is related to the diameter, smaller pulley diameter. Okay, depending upon these two data, we are going to select number of plies which are used for that belt. So already we have calculated this belt velocity in meter per second in step number 4. Okay, then in step number 2, for step number 1 only, you are going to select the minimum diameter of the smaller pulley. Okay, from the standard available data, and from that you are going to select number of plies. Suppose in our case we got that velocity as a 20 meter per second. We will take example as a 20 meter per second is the belt linear velocity, and the smaller pulley diameter which we are going to have is 250 millimeter. So it will become in this category, it is 20 and 250 millimeter. Number of plies which we have to use are the 5. This is one example. Suppose in case of other example, what we got is that the maximum belt velocity is 18 meter per second. Okay, and whereas the diameter of pulley is 200 millimeter. So what we'll do? Because this 18 is not in this chart, 200, let it be, this is the 200 value which we are going to get. So 18 which is coming either in between this 15 and 20, and in this case we are not going to have any value, as well as in case of this diameter 200 millimeter is coming in this category. So how many number of plies we have to use? So first of all, we'll see this speed is above 15 and below 20, right? So either it should be in this column, okay? And if the pulley diameter is 200, that means it is above 180 millimeter. So what we have to do is that 18, next value we have to take for the velocity, that is 20, and we have to take the next value for the diameter of that pulley, and hence we are going to get this ply as a 5. That is number of plies which are used as a 5. Rarely this thing happens, otherwise we are going to get the standard pulley diameters and values related to the speed. Do you have any doubt? Hello? Hello. Do you have any doubt related to the step number 6?
No, sir. No.
No. So we'll go to the next. Okay. In our table, okay, this minimum pulley diameter that has to be written in this column only, but as the space was not available, that's why I have written this next. Now next is step number 7, and that is finding the load rating at given velocity of the belt. Now here V has been written, it means that the velocity which we have calculated in step number 5. Sorry, in step number 4 we have calculated this velocity. Once you got this velocity, then for that velocity what will be the load rating that we have to calculate. Okay, and that load rating is calculated with the standard, what we can say, formulae, and at 10 meter per second velocity. Okay, and by considering 0.023 kilowatt per millimeter of the ply. That means for the each ply, for 1 millimeter, the power transmitting capacity is 0.023 kilowatt and at 10 meter per second belt linear velocity. Okay, don't go in details. This is what it has, how it is calculated. That's why load rating, while you are going to calculate for the particular velocity, at that time we have to select this load rating at 10 meter per second and velocity 10 meter per second. Okay, that we have already calculated, that is 0.023, and we have to put here the velocity which we have calculated. Just we have to know what will be the load rating at 10 meter per second, and we have to multiply it by means of value which you have calculated in step number 4 divided by 10, and that will be the kilowatt, that is power rating, load rating per millimeter per ply. If we are going to have 4 plies, then we have to again multiply whatever may be the answer which you are going to get with 4, because it has been calculated for each ply and for each millimeter. Are you getting me or not? Now this load rating at 10 meter per second, for the high speed we have to take this value as a 0.023, and for the front 949 this value we have to take as a 0.0289 here in this formula, and in second value which we have to put is the velocity which we have calculated with step number 4. If you are going to put these two values, you will get some value, right? Are you getting me or not? Suppose we got velocity as a 20 meter per second, then what will be the value here we are going to get for the load rating? I'm saying that the velocity which we have calculated with step number 4 as a 20, and if we are going to select the high speed 878 bell, then what will be the load rating for that bell? That will be equal to 0.023 multiply with V. What we have calculated is the 20 divided by 10. Can you just give me what will be the answer for this? Do you have a calculator with you? Hello? Do you have a calculator? Will you please calculate this value for me? 0.023 into 20 divided by 10. 20 divided by 10 is 2. 0.023 into 2. How much it will be?
0.046.
0.046. It will be kilowatt per millimeter per fly.
0.046.
0.046. Okay, it will be kilowatt per millimeter per fly. This will be the load rating for the case where the velocity which you are going to get as a 20 meter per second. Likewise, if suppose we are going to have already in step number 6, I think. Here, step number 5. If we are going to get this as a belt which we have to select as a front 949G, and in that case, how to calculate this value? What we have to change? We have to change this value, that is 0.0289 for the same velocity, suppose 20 meter per second. But the belt which we have selected is front 949. Then this value will get changed and answer will be definitely different. Got it? Any doubt? Hello? या स्टेप बद्दल कोणाला डाऊट आहे का?
No, sir.
हॅलो सर,
हा बोला.
स्टेप नाही बद्दल नाही, पण ते प्लाय म्हणजे काय समजलंच नाही, सॉरी.
ओके, प्लाय म्हणजे काय असतं की बेल्ट आपण जो मॅन्युफॅक्चर करतो तो बेल्ट एक स्टँडर्ड थिकनेसचा असतो. एक प्लाय म्हणजे एक स्टँडर्ड थिकनेसचा एक पट्टी असते. ओके, आणि त्या पट्ट्या एकमेकावर चिटकवल्या जातात आणि त्याचा एक मग फ्लॅट बेल्ट तयार होतो. त्या पट्ट्या एकमेकावर का चिटकवल्या जातात? जसं जसं आपल्याला पॉवर जास्त ट्रान्समिट करायची असते तसं त्या पट्ट्या एकमेकावर चिटकवल्या जातात. त्याला म्हणायचं प्लायज. आणि डाऊट? आता नवीन केस मध्ये काय झालंय की बेल्ट मॅन्युफॅक्चर करताना त्याच्यामध्ये असे धागे जोडले जातात. समजा आता हे जे ड्रॉइंग काढतोय मी, दॅट इज द ओरिएंटेशन ऑफ दॅट बेल्ट. धाग्यांचं ओरिएंटेशन असा अँगलने ते धागे जोडले जातात आणि त्याच्यावर दुसरे धागे असे जोडले जातात, त्यांची डायरेक्शन इकडे असते. हे झाले एक टाईपचे. असे जर आपण एकमेकावर धागे बसवले, चिटकवले आणि त्याच्यामध्ये रबर किंवा कॉर्क अशा टाईपचं मटेरियल बसवलं, ओके, तर तो प्लाय झाला. त्यानंतर सेम अशाच पद्धतीचा दुसरा प्लाय तयार केला आणि तो त्याच्यावर चिटकवला, तर तो सेकंड प्लाय झाला. त्यानंतर अजून तिसरा चिटकवला तर 3 प्लाय झाले. Got it?
येस सर.
Okay. Anybody else having any doubt? Hello? If not, we'll go to the next step. That is step number 8. That is the finding out the belt width. Now this belt which are available are in form of standard width also. But while we are going to select this belt, that is also depend upon the how much power we have to transmit by means of that flat belt. What will be the width of that belt? And that width of belt is given by B is equal to design power divided by number of plies multiplied by load rating. Now load rating which you have calculated in step number 7, whereas number of plies which you have calculated depend upon what is the load rating in previous step, as well as we have calculated design power in the previous step. And depending upon that, we are going to calculate what will be the width of that belt by means of this formula. Now, this formula you have to by heart because it will not be provided in any that chart which charts which are supplied to you. Okay, so this width of belt is calculated by means of design power divided by number of plies into load rating. Okay, these values for the design power, number of plies, and load rating are calculated by means of previous steps. Okay, and as you know that V is the velocity which is used for calculating load rating. Okay, after finding belt width, we must change it. That means if suppose we got the different width, then we have to change, okay, the velocity near a standard value of that velocity, okay, greater than the previous one, and fix the next value. That means at the time of problem solving, we'll see from this table. Okay, now these are the standard widths which are provided by means of manufacturer. Now, we suppose we are going to consider 3-ply belt, then that belt will have definitely 25 millimeter as a width, 32 millimeter width, 40 millimeter width, 44 millimeter width, 50, 63, 76, 90, and 100 millimeter. If you want to have belt with higher width than 100 millimeter, then we cannot go for the 3-ply. We have to go for the 4-ply belt if width is more than 100. Okay, even more we can go for the 5 plies. Even more we can go for the 6 or 8 plies if you want to have that width. Okay, I'm not saying that it will become depending upon whatever may be the calculation which you are going to do with the help of this formula. From this formula, if we got this belt width, suppose as a 43 millimeter, and number of plies which you have to use are 4. So 4 number of plies, which is the answer from step number 7 or 8. Selecting load rating is the 7, belt width 8. Number of plies which you have calculated from 6 number step. From 6 number step, if we got that number of plies are 4, and from step number 8, if we got the width as a 43, म्हणजे 4 प्लाय आहेत आणि 43 विड्थ आले, तर आपण कुठला बेल्ट सिलेक्ट करणार? 44 नंबरचा. ओके, दॅट इज 44 मिलीमीटर विड्थ असलेला बेल्ट, कारण 43 ह्या चार्ट मध्ये कुठंच नाही 4 नंबरच्या प्लाय साठी. मग आपण सिलेक्ट करतो 44. ओके, त्यानंतर इथं तुम्हाला हे जे डायमंड किंवा हा डॉट म्हणजे ते स्टार आहेत ऍक्च्युली, हे जे दिलेलं आहे हे आहे symbolic. The diamond indicates that size available in both high speed and front duck belt. म्हणजे हा डायमंड जो आहे तो डायमंड तुम्ही कुठल्याही टाईपचा, दोन्हीपैकी कुठल्याही टाईपचा जर सिलेक्ट केलेला असेल बेल्ट, जो की स्टेप नंबर 5 मध्ये आहे, त्या 5 मध्ये तुम्ही जो सिलेक्ट कराल तो 1 नंबरचा किंवा 2 नंबरचा, तर या टेबल मध्ये जिथं जिथं हा डायमंड आहे तिथं तिथं ते बेल्ट दोन्ही केस मध्ये अवेलेबल आहेत. दिस डार्क dot indicates that size available only in high speed, and this hollow dot indicates that size available only in front belt. Okay, म्हणजे हाय स्पीड मध्ये अवेलेबल असलेले आणि फ्रंट मध्ये अवेलेबल असलेले हे बेल्ट आहेत सगळे. गॉट इट? ह्या टेबल वरनं आपण सिलेक्ट करायचं. हा, आता ह्या 44 फॉर 3-प्लाय 44 विड्थ असलेला बेल्ट हा फक्त कशात अवेलेबल आहे? हाय स्पीड मध्ये. जर आपलं हाय स्पीड नसेल केलेलं तर हा 3 प्लायचा आपण सिलेक्ट करू शकत नाही, त्याच्या पुढचा करायला पाहिजे, म्हणजे 50. आपलं जर कॅल्क्युलेशन आलं 44 मिलीमीटर विड्थ आणि आपण जर सिलेक्ट केलेला बेल्ट हा हाय स्पीड नसेल, ओके, तर आपल्याला 50 मिलीमीटर विड्थचा बेल्ट सिलेक्ट केला पाहिजे. मग आर यू गेटिंग मी? किंवा ह्या केसमध्ये आपले नंबर ऑफ प्लाय झालेत 5 आणि विड्थ आले 180 मिलीमीटर. पण 180 मिलीमीटर ही फक्त फ्रंट डक्ट बेल्ट मध्येच अवेलेबल आहे. फ्रंट डक्ट बेल्ट मध्येच अवेलेबल आहे ते. पण आपण स्टेप नंबर 5 मध्ये सिलेक्ट केलेले फ्रंट डक्ट नाही आहेत, हाय स्पीड येतोय. मग काय करायला पाहिजे? 180 मिलीमीटर विड्थ तर आले, नेक्स्ट सिलेक्ट करायची, दॅट इज 200 मिलीमीटर. मग 200 मिलीमीटर हा अवेलेबल आहे हाय स्पीड मध्ये. मग आपली विड्थ, आपल्या बेल्टची विड्थ असणार 200. जरी कॅल्क्युलेशन 180 आली असली तरी आपण सिलेक्ट करणार 200. एनी डाऊट? हॅलो, डू यू एनी डाऊट? हॅलो,
No, sir.
no, okay, it's okay. I will stop today here.